Hello guys and welcome to my YouTube channel. Today I will be starting a new YouTube series where I will be going through how to build an autonomous robot from scratch. Now myself, I am Pedro and I am a computer science student which will start the masters this month here in the University of Luxembourg. So for the past 3 years or so, I've been kind of working with robots, essentially. I've worked with this Boston Dynamics bot, the Unitree, Go1, which are both legged robots. I've also worked with a DJI Telodrone and other drones, essentially. And so yeah, I've never really invested much time into differential robots. And so why this series? So I want to learn more about them, and hopefully throughout the series I will teach you guys, and also teach myself of course, more about these type of robots and how to build them. And so why the series? Now I'm calling the robot Perceptron bot. And so what you can expect from the series? Well, so the main goal is then to make this robot from scratch, so build it and then write software for the robot itself, and then later on use it on any type of experiment really you want to do. And so if you don't know what a differential drive robot is, well, if you know the vacuum cleaners, those are differential driver robots, sorry. And our Perceptron bot, it's this guy. I have made a prototype already in Fusion 360, and this is the end result I got to, and I have printed here. So the base layer, the base chassis, and yeah, here it is. I mean, it only has the motors and the frame itself. We have here this caster wheel I made so that we can have it leveled, and yeah. So this will be basically our goal. And so to achieve this, we will first need to design the robot itself. I will be using Fusion 360, which is a CAD software. Now, if you don't know anything about a CAD software and you want to design the frame yourself, then I advise you to learn more about a CAD software, because I will not really teach you guys how to use a CAD software, but I will show you what I did to achieve to this result. And so yeah, if you need to learn more about it, you might consider Fusion 360 or Onshape, which is hosted on the web basically. Both are free for personal use, so yeah, you can do whatever you want with it. So with the robot frame built, we will start making software for it. And so we will divide it into two different parts. The first will be low level development, and then high level development. And so what I mean by this is, so for the low level part, we'll be controlling the motors, any sensors we have, like for example ultrasonic sensors to know the distance to objects. And we will be using Arduino as our development platform basically, which is a easy to use, let's say a low level platform. And yeah, initially we will be doing then this motor driver, motor controller, and serial protocol. And so here on the right we can see that, so we have here the Arduino board, and then we will have a motor driver, which is the L298N in this case. And we will actually communicate with it via PWM signals, and so we will tell it to move at a certain speed. And then we can also set it to either move in the counterclockwise or clockwise directions. Now each of the motors will have an encoder, and this encoder information will go to the Arduino as well. So this way we will know how much the motors have moved since the start of it, since the start of the robot. And then we will have extra sensors, but for now we will keep it simple, and we will only have the motors for now because we need them to move the robot, right? Now the way we will communicate with the eye level, so we will need to communicate with this eye level part of thing, is via serial. And so we will need to create some basic serial protocol so that the PC can communicate to the Arduino board and the Arduino board can communicate to this onboard PC. Now we'll go later on for the different components, but this is basically a big overview you can think of. Now speaking of eye level, the eye level part will be basically using ROS, which is the robot operating system, but I like it to call it more a framework really, because this is not really an operating system. And so yeah, the main thing we will want to do here, or at least to start with, will be then to use this navigation to stack, which is part of ROS2, and this will enable us to make our robot autonomous. So we will be able to map the environment where the robot is, and then later on choose, for example, a point on that map, and the robot should then follow or create a trajectory to this point we gave it. And yeah, so that's basically it for the start of the eye level software. Well, in addition, we will need to create this bridge that will communicate with the Arduino side of things. So that way we have the protocol running on the Arduino, and basically we have another protocol running on our eye level, which will be a ROS node that then will communicate with the Arduino for example, sending, oh, move forward and move left and move right, etc. Now, if you haven't seen it yet, we will be using ROS2, and it's a nice framework to work because it's very expandable, and I mean you can do a lot of things, and many robots nowadays just use ROS as their base framework and then build on top of it, and so that's basically what we will do as well. So in addition to this low level and high level, I want to also make our robot work in a simulator. Now ROS provides us with Gazebo, which is a simulation environment, a simulation application, and so we will basically build our own robot into this Gazebo, and then we can simulate from there. So we don't really need the robot itself to basically test things. We can just use the simulation, and that way we can test first, and then later on put it on the actual robot, and then yeah, test on the actual hardware, right? Yeah, so here's the architecture. So we have basically the hardware, right? So the motor drivers, any sensors we will have, yeah, basically that's all, essentially. And all of these will communicate to the Arduino, either be a PWM, I2C, UART, you name it, depending on which type of sensor we have, for example. You don't really need to know what these are, but these are just basically protocols you can use to communicate with the Arduino. And PWM is the one we will be using to control the motors. And if you don't know what PWM is, it's shorthanded for pulse width modulation, if I'm not wrong. And it's basically, so we can regulate, for example, a voltage depending how. So if you think of a switch, we can either turn it on and turn it off, and if you turn it on and off at a frequency, we'll be able to regulate this voltage, for example, to half of it. So if you have like 12 volts and for, let's say, half the time you have the switch on and the other half the switch off, this will basically mean you will have 6 volts, let's say, the half of the voltage, the total voltage. Now this is a very abstract explanation. I'm not even like 100% sure I am correct, but I hope I am. In any case, you can search what is PWM. And so, as I said, we will communicate with our onboard PC via serial, and then the onboard PC will be running ROS. And that's basically it. So now, what are the components we will be using? Now, these I am sure we will need to use, because I am starting to build something to prototype. And so yeah, these for sure we need. So, as I said, we need a DC motor. And this DC motor is important that you have an encoder. Now, there are motors that do not come with this encoder. So this here at the back, this is the encoder. And you can buy just a DC motor. And then you can also buy just the encoder itself. But I prefer to buy this one, which already comes with one. So, and it's very, this motor itself is very popular on the robots themselves. And so to control this guy, we need this motor driver. Now there are other drivers, of course, but this one is a popular and cheaper one. So the L298N. And this guy will control 2 motors. One board controls 2 motors, which is what we want. Now we need a Arduino board. I've chosen the Nano because, at least for the first part, we don't really need much power. And so the Nano should be plenty for what we need. And for the onboard PC, I guess the most popular choice would be a Raspberry Pi 4. I would say with at least 4 gigabytes of RAM. But since nowadays it's very difficult to get one, I have found basically another board that you can use. And I mean, there are other, of course, but I've chose the Aldroid N2. I don't know if I have, I don't think I have, but I can show you. Aldroid N2 Plus. So yeah, it's this board right here, which apparently on paper is even more powerful than the Raspberry Pi. The only disadvantage I see from this board is that you don't really have any Wi-Fi or Bluetooth capabilities integrated into the board, so you need to use a dongle for sure. But actually, on the other hand, I've seen that the Raspberry Pi's price and the availability are starting to come up again. So, or the availability is coming up and the price is going down. I have bought this Raspberry Pi with 4 gigabytes for 80 euros, I think, on Amazon. So you might consider the Raspberry Pi, or if you have one, even better. I do not advise you to have the 2 gigabyte model, because that might be too low for our purpose. So we'll also need a buck converter. The reason is because we will have a LiPo battery to power our robot, and this battery itself is, so the nominal voltage is of 14.8 volts, and one charge is of 16.8 or something, I don't know, 16 and above. And so we need to bring it down to 12 volts to power our motor driver, our onboard PC. If you choose the Raspberry Pi, you will need 5 volts. If you go for this Aldroid N2, well, it's 12 volts, so you are good to go. But basically, this driver also provides you 5 volts, so I guess one should be enough. And then you also need a 2D LiDAR, and this will be used for mapping the room, which will create a point cloud basically of your room. Now we will later on most likely add extra sensors, and the ones I'm planning to add for sure is a camera. Now if you have the Raspberry Pi, you can go for the Pi camera, for example. It's pretty cheap, or any webcam really. Like if you have old webcams, you can use them as well. And also a ultrasonic sensor, so to put it in the front of the robot, and that way we can prevent the robot from going to stairs, for example. By positioning this ultrasonic sensor a bit tilted down, we'll be able to see if there is some distance. It means that, well, there's some stairs or something that the robot should not go in, right? So we need some requirements. So if you want to proceed with this series and you want to make your own, first of all, the Raspberry Pi will need to run Ubuntu, I believe. I don't think you can run, for example, the Raspberry Pi OS. Maybe I'm wrong. At least when I tried like some years ago, I could not, so maybe you can now, but I'm not sure. You can just run this Ubuntu. I might be running the Ubuntu server, which is light, because we don't really need the GUI interface. So but if you don't feel comfortable with using terminal, but then you can just use the normal Ubuntu. And so if you use Fusion 360, you will need to either use Windows or Mac OS, because it only runs on those platforms. Hi guys, while editing the video, I forgot to mention that you actually need to have Ubuntu to run or to develop the software for ROS mainly, because ROS, you can run ROS in Windows or Mac, but it's not the main platform, so just stick to Linux. Now I forgot to mention, so the components, these are not all the components, but you will need screws, you need to print the frame, and you need some other parts I'm not listing here, but these are the components that you need to make the robot move basically. And so of course when you build the robot, you will need, for example, a soldering iron, general tools like a screwdriver, pliers, whatever you might need. And yeah, okay, so for the timeline, so this is what I'm expecting to record. So the first thing, in the next episode will be then about creating the robot platform using a CAD software. And then from episode 3 to 5, this will be about low-level development, where we'll start smaller with the motor driver, and then the motor controller, and then the serial protocol. So the difference between the motor driver and the motor controller, it's pretty simple. The motor driver basically just communicates with the L298N driver, and it's just for a single motor. And then the motor controller is basically responsible of controlling the two motors and receiving higher level commands. And most likely it will, I'm not sure if I will do it on the motor controller to compute the odometry, or if I will do that in the high level part of things. And then we will then develop this serial protocol, which will be as simple for now, just to be able to communicate with Arduino and Raspberry Pi. And now from there on, it will be most likely just high level. And so we will start to create our robot in simulation, in Gazebo, and then work upon it. So we will definitely need to write a Rust package to control the motors, so it will communicate with the Arduino via the serial we wrote on episode 5. And then the last step will be then to integrate the navigation to stack. And that way we will have a robot that essentially navigates autonomously. And now from there on, I still don't know. I mean, you can suggest what you want me to do and whatnot. Now regarding the episodes, I mean, I'm not really sure this will be the exact order, because for example, let's say the creation of the robot, I might add another episode just to build the robot and things like this, but for sure these episodes will be on the series. Okay, and yeah, that's all for this presentation. Now I have created a GitHub repo already. I will leave this link in the comments down below, or in the description rather. And so here it's where you will find everything related to this project. I will add eventually the CAD files, and so I already created a basic just the package itself for the low-level development, and we will also have a high-level development repo which is just for that, because that will need to be transferred to the onboard PC basically. And then here I will also add any documentation we might need, any guide, anything. And I already started adding here the builds of materials. So this is where you can find exactly what all the components you might need, as you can see here. So you have the links already here. Yeah, as you can see now we have more stuff. So we have you will need an XT60 mounting for the battery, a bearing for this caster wheel. I show you here. So this caster wheel here has a bearing, and then we have O-rings also for the caster wheel, so that I don't know if you can really see it, but yeah, this black is O-rings, and you just to have like a rubbery texture on the wheel so that it doesn't slip basically. And then I listed here the optional ones I listed on the presentation, apart from the IMU actually, and then some tools you might consider buying if you don't have them. I will add more stuff here eventually when I know all the items we need. So yeah, this will for sure be updated soon. Yeah, I think that's all now. So I hope you have enjoyed this first episode, and also my first time recording on YouTube. So if you have any suggestion how to improve the quality, or any critical advice, really, I am open-minded. So feel free to leave a comment if you desire so, leave a like, and yeah, subscribe if you're interested, and see you on the next episode.